Students, A2 chemistry, chapter is electrochemistry, lecture number 1. In this video, we are going to start with the most important topic of electrochemistry, that is standard electrode potential. Now, as you can see, standard electrode potential is a combination of three words: standard, electrode and potential. To understand electrochemistry at this level in A2, you must be able to have a detailed explanation of each of these words in your mind. You must know what is an electrode, you must know what is the potential, and what is the meaning of standard word in standard electrode potential. Okay, let's start with the first word, electrode. Electrode, you people are studying from your elementary classes. What is electrode in chemistry? So generally speaking, you can say electrode is any charged elemental plate or rod. I have used the word element because electrode, you know, it is made up of metal as well as non-metal. For the time being, in your elementary classes, you have seen only one non-metal electrode you people would have studied. It is graphite, carbon, non-metal in the form of graphite. But remember that now we in A2 chemistry, we will also construct certain half cells, certain cells having other elements also used as electrode. So that is why I have used the term any charged elemental plate or rod, it can be known as electrode. Next thing you must remember, there are two types of electrode that we study commonly in chemistry. One type of electrode, it is known as anode, and the other type of electrode you people are familiar with, it is cathode. Now, do you know what is the difference between anode and cathode? Okay, uh, whenever someone is asked what is anode, mostly people say anode is positively charged, cathode is negatively charged. Okay, why you people define anode and cathode with respect to the charges? Because from your elementary classes, you people are looking at cathode as negatively charged plate and anode as positively charged plate, but remember, it is incorrect. It is wrong. It is not correct to define anode and cathode with respect to the charge. Anode can be negative, anode can be positive. Cathode can be negative, cathode can be positive. So it is best to define anode and cathode not with respect to the charge, rather with respect to the process. So what you must remember now for your future, for your higher levels, if you are studying chemistry, what you must remember: what is anode? Anode is the electrode at which oxidation takes place. This is the best definition for anode: electrode at which oxidation takes place. And cathode, cathode is the electrode at which reduction takes place. Anode, where oxidation takes place; cathode, where reduction takes place. I can give you a shortcut, a trick how to remember this easily, how to memorize this easily. Just remember red cat. Red cat, red for reduction, cat for cathode. It means reduction always at cathode. When red cat, you will remember that reduction always takes place at cathode. Obviously, anode will be for the oxidation. But you can also remember for anode, if you wish to, you can remember anox, anode for oxidation. So this is the best way to define anode and cathode with respect to the processes. Now, never ever in future, as A level student, you should define anode or cathode with respect to the charge. Okay, I'm going to explain that anode can be negative, anode can be positive. Let's see. Okay, next thing, whenever we combine in a setup, we combine these two electrodes and anode and cathode, then that setup, what it is known as chemistry, it is known as cell. What is a cell? Cell is a combination of anode and cathode that shows redox reaction, where redox reaction takes place. So any setup where cathode and anode are present and redox reaction is taking place, it is known as cell. But generally speaking, you can say combination of anode and cathode electrode, it is, that setup is known as cell. Now in chemistry, generally there are two types of cells that we study commonly. One type of cell is known as electrolytic cell. This is one type of cell that we study commonly in chemistry. The other type of cell that you people are not familiar with yet, or you might have studied one or two example in your elementary classes, but mostly in your A2 chemistry, in this chapter, we will study this type of cell. It is voltaic or galvanic cell. So you must remember there are two types of cells, generally electrolytic and voltaic and galvanic. Now what are the main differences or what are the main features of each of these two types of cells? First of all, for electrolytic cell, so what you should remember, the most important thing, electrolytic cell is a cell in which electrical energy it is converted to chemical energy. Whenever in a setup electrical energy is converted to chemical energy, that is known as electrolytic cell. What is voltaic or galvanic cell? It is opposite. It is opposite to the electrolytic cell. In voltaic or galvanic cell, chemical energy it is converted into voltage, chemical energy is converted into electrical energy. So just remember the important features of electrolytic cell. For voltaic or galvanic cell, you can write down these features yourself, but remember for A2 chemistry, we will focus on voltaic or galvanic cell. All the cells that we will discuss, they are voltaic or galvanic cell, and some examples of electrolytic cells at the end, and calculations we will do using electrolytic cell. Otherwise, voltaic or galvanic cell is the main focus of this chapter. Okay, second feature that you must remember, when electrical energy is required in electrolytic cell, always we use a source of input. We use a source from where electrical energy can be provided. You can remember the source of input as battery. Battery is the source of input. As compared to electrolytic cell, in voltaic cell, instead of source of input, we have a source of output, because voltage is being produced. Voltage, when electrical energy is given out, so we use something where we can consume that voltage. It can be in the form of a bulb, it can be in the form of some other electric motor. So that voltage or electrical energy that is being produced, we can use it to perform some work. So remember, even sometime in some cases, to measure that electrical energy, you can use the instrument voltmeter. So in case of electrolytic cell, there is source of input, but in case of voltaic cell, there is always a source of output that can tell us what is the voltage, what is the electrical energy produced by that particular cell. Next comes, in case of electrolytic cell, anode is always positive and cathode is negative. Now why is so? That is why you people have learned that cathode is negative electrode and anode is positive. Why it is so? Because from your elementary classes, you people are studying which type of cells? You people are studying electrolytic cell. So that is why you have make up your mind that cathode is always negative and anode is always positive, but this is not the case. I will tell you in case of voltaic cell. So for electrolytic cell, cathode is negative, anode is positive, but for voltaic cell, anode is negative, cathode is positive. Remember this information. This is most important information for this chapter. In all the lectures of electrochemistry, you will see we will study again and again anode is negative, anode is negative in voltaic cell. Okay, I'm giving you a diagram. This diagram you can look at and you can identify quite easily this is which type of cell. Okay, if you look at this electrolytic cell, this is why this is electrolytic cell, because you can see there is a source of input. The source of input or the source of output, it is a clear indication in the diagram whether the given cell is electrolytic or voltaic or galvanic cell. This there you can see a source of input, a battery is there. You can see the larger terminal is always positive, the smaller terminal is negative. Whenever we connect an electrode with the larger terminal, that electrode gets positive charge, and you, as you have remembered, that electrode becomes anode, and the smaller terminal whenever it is connected to an electrode, that electrode becomes negative, and that you have remembered as cathode. So remember, whenever you have been given this type of diagram, this is an electrolytic cell, because you can see there is a source of input. Compared to this, look at the diagram for the voltaic cell. This is a beaker or other container. This is the electrolyte. We dip into electrodes. We will connect this electrode with the one terminal of the voltmeter, or you can use bulb or any other output source. Right now I am using voltmeter. The voltmeter has two terminals. We will connect the other terminal to complete the circuit with the other electrode. This is electrolyte. Now if I label these electrode as X and Y, and if I ask which one will be negative, which one will be positive, you cannot tell me. But in the previous case, you were able to tell me which electrode is negative, the one that is connected to the smaller terminal, the other that is connected to the larger terminal, that was positive electrode. But now you cannot tell me. But if I give you the exact identity of these elements, these electrodes, you will become able. See, Y is Mg, magnesium metal, X is Cu, copper metal in this case. Now I think most of you would have understood that which electrode would become negative, which one would become positive. See, both of these are metals. Which one of these two is a reactive metal? Mg, magnesium, is a reactive metal, and reactive metals can undergo which process easily? Reactive metals can undergo oxidation easily, loss of electron, they can lose electron easily. And oxidation takes place at which electrode? I have told you in the beginning of this lecture, oxidation takes place at anode. So magnesium is undergoing oxidation, it is anode, and what I have told you in the voltaic cell, anode is always negative. How it is negative, that I will explain in the next lecture, don't worry about that, but just remember for the time being that anode, it is negative. So in this case, you have come to know, whenever you have been given two elements, the metal that is more reactive, it will undergo oxidation, it will become anode, and it would carry negative charge. So this information you can guess now after you have been given the exact identity of the electrode used. Now compared to Mg, the copper would have to undergo reduction, it will become cathode, red cat, and it will carry positive charge. Now you can see in case of voltaic or electrolytic cell, you can identify anode and cathode once identity of each electrode is given. Next thing, commonly so many cells we are using in our daily life, you can see there are some type of cells that are not rechargeable. Those cells which cannot rechargeable, they are examples of voltaic cell. They are examples of voltaic cells. The examples of electrolytic cells you people have studied in your previous classes. For example, whenever a cell is used for purification of copper, for electrolysis of water, those cells are types of electrolytic cell. Even any cell that we use for electroplating, so that is also electrolytic cell. So generally speaking, whenever you use electricity, you use a source of input, that is electrolytic cell. Can you guess, can you tell me that the battery, the cell we are using in our motor vehicles, it is which type of cell? Yes, okay, some of you might have guessed it correctly. Remember, whenever we have a rechargeable cell, rechargeable battery, like your car battery, like your mobile battery, like your laptop batteries, all these batteries which are rechargeable, they are both types of cells. They are both types of cells. They are electrolytic as well as voltaic cell. When you will charge that battery, it is acting as electrolytic cell, and when you are using that battery, it is acting as voltaic cell. For example, the laptop, when we are charging our laptop or we are charging our mobile, then in that case it is the electrolytic cell, because we are giving input, we are charging the mobile battery. And when we, after charging, when we are using the mobile phone or we are using the laptop, what is happening, the energy stored, it is providing, it is converting into electrical energy, and that electrical energy is giving us some output. So then in that case it becomes voltaic or galvanic cell. So you must remember, in our daily life we are using all types of cells. Okay, now you have come to know what is electrode, what is a cell. Before we proceed to the potential and standard, let me tell you one more thing. the differences between electrolytic and voltaic cell you have come to know. Now if ever it is asked what are the similarities between electrolytic and voltaic cell, one similarity you can remember in both these cases, which reaction takes place, redox reaction. Whenever, whether there is electrolytic cell or voltaic or galvanic cell, the process, the reaction that takes place, it is redox reaction. And second feature that is common, it is the direction of flow of electron. Yes, in chemistry always you are asked highlight, indicate the direction of flow of electron. Always direction of flow of electron in chemistry is from anode to cathode, from oxidation to reduction. So likewise you can see in the electrolytic cell, the electron, they are flowing from anode towards cathode. Likewise, even if you have been given voltaic cell, the direction of flow of electron will always be from anode to cathode. So remember two similarities of these two types of cells, electrolytic and voltaic. They they undergo redox reaction, and direction of flow of electron is always from anode to cathode or from oxidation to reduction. Okay, next comes the potential. Potential you would have studied in physics what is potential, but right now I am going to tell you a simple explanation meaning of this term, what is potential in chemistry. In chemistry, potential, simply you can remember, it is the ability. What is potential? It is the ability. It is the ability of an element. What an element can do? You people know an element can have two abilities. Either an element can lose electron if it is a metal. An element can gain electron if it is a non-metal. So remember that there can be two different types of abilities or potential of an element in chemistry. An element is able either to lose electron or it is able to gain electron. So generally, whenever you see the word potential, what must come in your mind? Potential is the ability. Potential is the ability, and there are two types of potentials in chemistry we study. One is oxidation potential, other is reduction potential. Oxidation potential is for those elements which lose electron, which undergo oxidation, and reduction potential is for those elements which gain electron, which undergo reduction. Oxidation potential, whenever an element would have oxidation potential, what electrode it will become? Yes, I told you, in A2 where there is oxidation, that electrode will become anode, and that plate would get negative charge, because anode is always negative in A2, all voltaic or galvanic cells. So during oxidation potential, a plate will become negative, a plate will become anode. And this is the property of which type of elements? Mostly reactive metals, they have oxidation potential. While whenever there is reduction potential, the plate, the electrode will become cathode, and the electrode would get which charge? It would get positive charge, and this is the property of less reactive metals and non-metals. So you must remember, right now the potential is the ability of an element. So right now, out of three words, two words you have come to know. What is electrode? What is potential? What is electrode? What is potential? You have come to know. Now the last word I am going to explain, what is the meaning of standard. Standard means, whenever we study electrode potential, we always study electrode potential of different elements under standard conditions to make a fair comparison for their electrode potentials. What are the standard conditions? Typical standard conditions we use for electrochemistry. One thing is standard temperature of 298 Kelvin or 25 degrees Celsius. 1 atm pressure is used if ever there is a gas. And solution, whenever we prepare the solution of an electrolyte, its concentration is always taken as 1 mole per dm cube. So these are the standard conditions, commonly used, typical standard conditions for electrochemistry. One more condition sometime we use, it is that standard electrode that we have to use sometime, it is made up of platinum metal. Why we use platinum metal? Two reasons. Number one, platinum is inert, it does not generate its own potential. Number two, platinum is a metal, it is a good conductor. So when standard electrode platinum is used, why it is used, I have told you, because platinum is a good conductor and it is inert, unreactive itself, it will not generate its potential. When it is used, there are two possible ways. Now in A2 you will see there are many electrodes, many cells that would have non-metal electrodes. whenever you want that a non-metal should act as an electrode, you know what is the problem with non-metal? Non-metals are non-conductor. So in that case, how the charge will be conducted? The charge will be conducted by using platinum. So wherever there is a non-metal acting as an electrode, you will use platinum as an electrode, as a standard electrode. And second thing, mostly what happens, whenever we have an electrolytic solution, there is only one type of ion. For example, if I give you copper sulfate solution, which positive ion is present of copper? Cu2 plus. But sometime we prepare some solutions when same solution contains one element in two different oxidation state. Whenever one solution contains same element in two different oxidation state, even then we will use which electrode? Platinum. For example, I can tell you, if a solution contains both Fe2 plus and Fe3 plus, you will have to use which electrode? Platinum. If I give you a beaker containing Fe2 plus solution only, you can use iron electrode. If I give you a solution containing Fe3 plus solution only, you can use iron electrode. But if I give you a beaker containing a solution of both Fe2 plus and Fe3 plus, then you will have to use platinum. Why? I will explain later on. Okay. This video has given you an information what is standard electrode potential, what basic information you must remember about standard electrode potential to understand electrochemistry in A2. Thank you for your time. Bye bye.